Right, section 1.3, using midpoint and distance formulas. Okay, first our objective for today is to find a segment length using midpoints and segment bisectors, and we're going to use the midpoint formula and use the distance formula. The F kind of got cut out there, that's an F formula. Okay, so first we have a little bit of vocabulary. We have to give a formal definition of what a midpoint is. A midpoint is the point that divides a segment into congruent segments. So if I have a segment, let's go ahead and let's draw a segment here. And let's label it A, B. Okay. And if I wanted to divide it into two congruent segments, if I have a point here in the middle, M, and if it divides it into two congruent segments, so that segment AM there, is congruent to segment MB, then we know then that M is the midpoint. Okay? And we can mark congruence. We actually have a congruence symbol. In geometry, we use notches to mark congruence. So I would put one notch here and one notch there. We use that, I call them notches, other people call them tabs or tick marks. Sometimes they're called tick marks. But if two segments have the same number of tick marks, then that means they're congruent. Since this has one tick mark and that has one tick mark, they're congruent. Now, if it had two tick marks and this one only had one, then that would show not congruence. Okay, so there's a quick and easy way to say two things are congruent. Okay, so now that's a midpoint. So a midpoint, again, highlighting the idea that it's a point. Okay, now if you have either a point, a ray, a line segment, or even a plane that intersects the segment at its midpoint, then we call it a bisector. Okay, so we call it a segment bisector. It needs to intersect or go through the segment, intersect at its midpoint. So a segment bisector could be a point, a ray, a line segment, or a plane. Okay, and we say then that it bisects the segment. So a segment bisector, of course, then bisects the segment. Bisector meaning it cuts it into two congruent pieces. So a segment bisector, again, could be a point, a ray, a line segment, anything that basically goes through the midpoint of a segment. Okay, so here, example 1. In the figure, P to M, again, there's no segment sign above it, so we're talking about the distance from P to M is 1.8 millimeters. So I'm going to label that. This distance from P to M, this distance here is 1.8 millimeters. Identify the segment bisector of segment PQ, then find P to Q. Again, this no segment above it, so that's talking about distance. It wants me to find the distance from P to Q. So we're looking for this whole distance. Plus, we also need to identify the segment bisector. So if I'm looking at this segment from P to Q, so we're looking at the whole segment from P to Q, we're looking for what goes through the midpoint. Well, you see I have one notch here and one notch here, so that identifies this here as the midpoint. I'm looking for what figure is going through the midpoint. Well, the midpoint here, we've got, it looks like a thing that starts here at M and goes this way for forever with the arrow, so that to me looks like a ray. So the segment bisector is that ray that starts at M and goes towards T. So ray MT is the segment bisector. And then we're looking for this whole distance from P to Q. Well, if M is the midpoint, if this distance is 1.8, they're congruent, so that tells me this distance also must be 1.8. And using then the segment addition postulate, I know that PM plus MQ has to equal PQ. Well, we know P to M is 1.8 plus M to Q is 1.8 equals PQ. So that tells me the distance from P to Q, 1.8 plus 1.8, which is 3.6. Put units, millimeters. So here's the segment bisector. The segment bisector is a ray. And here is P to Q, 3.6. Okay, extra example 2. point M, they tell you point M here is the midpoint of segment AB. So that tells me that A to M is congruent to M to B. Find the length of segment A to B. So since M here is the midpoint, I know that A to M is congruent to M to B, which tells me that their distances are equal. The distance from A to M is equal to the distance from M to B. But we know the distance from A to M. They give it to me. It's that guy right there, 3x minus 4. That has to equal, they give me the distance from M to B. That is 2x plus 1. And they're wanting me to find the length of the whole segment. So I'm looking for the length of the whole segment. Okay. But I can't really figure that out until I know what x is. Okay. I need to figure out what that x is so I know how long AM is and how long MB is. So I can use now this congruence statement, this equality, and I can solve for x. So I'm going to add 4 to both sides to get x by itself. Okay, so minus 4 plus 4, so 3x equals 2x plus 5. Now I'm going to subtract 2x from both sides. Okay, 3x minus 2x is x, so I know x equals 5. So I know x is 5, so now I can plug that in here for this x and for that x. So there, if x is 5, that'd be 3 times 5 minus 4. 15 minus 4, that gives me 11. I can put it in there, that would give me 2 times 5 plus 1. 10 plus 1 is 11. So they're both 11. Well, we would expect them to be the same because M is the midpoint. So the whole distance from A to B then would be the 11 plus the 11. A to B is 22. And we don't have any units on it, so we'll just label it as 22. Okay. All right, now we're going to do a new construction. A construction is bisecting a segment. We're going to bisect the segment by paper folding. That's actually the quick and easiest way to bisect a segment. There's another way using a compass, and we'll look at that later on. But if I'm just wanting to find the midpoint, the easiest way is by paper folding. So I'm going to come down here and I'm going to draw any segment. And a lot of times it helps to draw the points dark. Call it A, call it B. And now to find the midpoint, all you do is you fold it over and you put A. Again, you may need to draw them super dark. Sometimes tracing paper is helpful. You place A on top of B, crease it, and there is your midpoint. There's my midpoint right there, M. Okay. Not anything much to it. Tracing paper sometimes helps because it's a little thinner and easier to see through. Okay, all right. All right, the midpoint formula. Okay, if I'm given points on an ordered pair. So if I'm given the points on a coordinate plane. So on my xy coordinate plane here, if I'm given my points on my xy coordinate plane, I can actually find the midpoint by averaging the x's and averaging the y's. Okay. What I mean by that, okay, let's just go ahead and let's do a random point here. So let's go ahead and let's use this point down here. And let's say I don't know the scale, so I'm not entirely sure what that point is. So we're just going to call it x.1, comma xy.1. These are subscripts written down below, down in the corner. So this is point x1, this is point y1. Okay, let's put another point over here. Again, I don't know what that ordered pair is because I might not be counting by ones here. So let's call that x.2, comma y.2. So I have a segment made out of these 2 points. And I'm looking for the midpoint of this, okay, of this segment. Okay. I can actually find that midpoint by averaging, let's come over here, we want to average the coordinates. Okay. So to find the x coordinate of my midpoint, so we'll go capital M for midpoint, is going to happen at the average of my x coordinates. So I have 2 x's, Again, to average two numbers, you add however many numbers you have and divide by however many numbers you have. So here I have 2 points, 2 x's, so I'm going to add my x's. So I'm going to take x1 and add it to x2. And then I'm only adding 2 points, so then we'll divide that by 2. So that will give me the x coordinate of my midpoint. Okay, comma. Now we average our y coordinates. So now I'm going to add my y coordinates and divide it by 2. Okay, and that gives me the coordinates of my midpoint. Okay. All right, so let's go ahead and let's do an example using this, and you'll see how straightforward and easy it is to use. Okay, so here, example 3, the endpoints of segment AB are at -8, 7. So let's plot that. -8, 1, 2, 3, 4, 5, 6, 7, 8, and 7. 1, 2, 3, 4, 5, 6, 7. So it's going to be way up here. There's point A. Point B is at 5, 1. 1, 2, 3, 4, 5, 1. There's point B. So my segment is going to be about like this. So now, again, point A is at -8, 7. B is at 5, 1. We want to label our points. So now I want to find the midpoint. So first thing is I need to write the formula down. Again, please write it down every single time you use it. x1 plus x2 divided by 2. It'll help it stick in your head. Okay. So now I need to take my x's, add them, and divide by 2. So let's just plug it in. So let's take my x's. It's a -8. My x here is 5. So let's take -8 plus 5, divide it by 2. Now let's do the same thing with my y's. 7 and 1 will go 7 plus 1, divided by 2. So -8 plus 5 is -3. -3 divided by 2 is -3/2, or -1.5 if you'd rather have it as a decimal. Okay. Now let's do my y. 7 plus 1 is 8, divided by 2 is 4. So my midpoint occurs at -1.5, 4. -1.5, 1, 2, 3, 4. There's my midpoint. Again, my scale is probably off just, oh, I didn't go 1.5, that's why. -1.5, 1, 2, 3, so it should be more right about there. Should figure it out. Oh, sorry, you couldn't see it anyway. -1.5, 4. There's my midpoint. So this point is the same distance from A to M as from M to B. Okay. So now for part B, the midpoint of segment PQ, I'm going to switch colors so I'm confused. The midpoint of segment PQ is at 2, -3. 1, 2, -3. This is the midpoint of segment PQ. One endpoint is at 4, 1. 1, 2, 3, 4, 1. So there's P. So I know I have a segment, okay, that's going to go to M. P, go through M, and come down here. Q is going to be down here somewhere. We need to figure out what point Q is. M is the midpoint. M is this point M. So we're looking for the coordinates of point Q. So we know Q is going to have some coordinates X and Y. Okay. I just need to figure out what they are. But I know its midpoint is going to be at the point 2, -3. That's its midpoint. But I know based on the midpoint formula, I add the x's and divide by 2, add the y's and divide by 2. But I only know one of the x's and y's. I only know one x and one y. I'm trying to find the other one, so I'm going to need to use some equations. Okay, so I know that this, after I'm done figuring it out, is 2. I know one of the x coordinates is 4. So let's replace it for one of the x coordinates. I know 4 plus x2 divided by 2, and I end up getting this 2 out. Okay, so that's how I found this midpoint, the x coordinate of that midpoint. And I do the same thing for my y. My y here is 1, so I know 1 plus y2 divided by 2 gives me that -3. So now I have two separate equations to solve that will give me this x and y. So I'm going to multiply both sides by 2 to start, to get rid of the divide by 2. 4 plus x2 equals 2 times 2 is 4. Now I need to subtract the 4 from both sides. So x sub 2 is the point 0. So that tells me my q has the order pair 0, comma. Now to find the y, I do the same thing here. Let's multiply both sides by 2. 1 plus y2 equals negative 6. Now I subtract 1 from both sides. So y sub 2 is negative 7. So my point Q is at 0, negative 7. 0, 1, 2, 3, 4, 5, 6, 7. Which that looks like it lines out pretty good. My point Q is down here. Right about there. So point Q is down here. Point P is up here, and M is that midpoint. Okay. So that's our midpoint formula. Two different ways of using it. Either finding the midpoint, like we did here in example 3A, or finding one of the endpoints if we're given the midpoint, like example 3B. Okay. All right, one last thing, the distance formula. Okay, we'll talk in more depth where this distance formula comes from. Okay, but really the basis of it is, again, I have 2 points. Let's do my x1, comma y1 point, and my x2, y2. Just like in our midpoint formula. And I want to know this distance. I want to know how far this is. This distance right there. Okay. The gist of it, the skinny of it, is I actually create, this is where this distance formula comes from. We will discuss when we go over right triangles and Pythagorean theorem. We'll discuss a little more where it comes from. What we do is we create our vertical change and our horizontal change. This vertical change, as we change, go up and down. Again, up and down is y. How we get to that is we take the y coordinates and subtract them. I take this y coordinate and subtract this one down here. So I get y2 minus y1 for this piece. And so then this length is, again, the difference in my x's. So I say x sub 2, subtract x sub 1. Okay. And then using the Pythagorean theorem, which if you remember from Algebra 1, a squared plus b squared equals c squared, where c is the hypotenuse, which is my d there. So, and this would be my a, this would be side a, this would be side b. Okay, or I guess we can do it the other way around, that might be easier. If this is side A and this is side B. So I take the side A and square it. So I take x sub 2 minus x sub 1, that whole side, and square it, plus y sub 2 minus y sub 1, take the whole side and square it, and that equals d squared. So then I would need to square root both sides to get rid of this d squared. Again, this will make way more sense when you do Pythagorean theorem. Really all you need to know is to find the distance between 2 points. You take the square root of the whole thing, subtract the x coordinates squared, plus subtract the y coordinates squared. And that gives you the distance between any 2 points. Okay. So this is really all you need to know for now. We'll discuss more in depth where it comes from. I just wanted to show you a little bit that isn't just magic. It wasn't just made up. It actually comes from something else. But these are really the 2 important things you'll need to know. We'll add them up to a chart on the wall before your first skill check. So if there isn't one up, please remind me. Okay, and we just have one more example to do here, example 4. Okay, your school is 4 miles east, 1 mile south of the apartment. So let's go north, south. So this would be west, this would be east. Okay, so your school is 4 miles east and 1 mile south of your apartment. So let's say your apartment here's at the center. We're 4 miles east, 1, 2, 3, 4. 1 mile south. Okay, so there's the school. We'll put an S on it. A recycling center, where your class is going on a field trip, is 2 miles east and 3 miles north of your apartment. So we decided your apartment here as at 0, 0. So we need to go 2 miles east and 3 miles north. 2 miles east and 3 miles north. 1, 2, 3. Okay, that's our recycling center. We'll call it R. Estimate the distance between the recycling center and your school. So first of all, we got to estimate this distance right here. This is what we're looking, and then we'll find the distance exactly. I'm thinking it's probably down 1, 2, 3, 4, maybe a little more than 4. My estimation is going to be in between 4 to 5 miles. Okay, so now let's actually find it using the distance formula. So let's give these ordered pairs. This R has the ordered pair 2, 1, 2, 3, 2, 3. This S has the ordered pair 1, 2, 3, 4, negative 1. So let's write the distance formula down first. Okay, so now it doesn't matter which one you let be 0.2 or 0.1, okay, as long as you're consistent. So I'm going to put a little 2 here because I'm going to have that be 0.2. Put a little 1 here. I'm going to have that be 0.1. So now I take x sub 2, so take the x coordinate, so let's do the whole square root, parentheses, so let's take the 2, subtract the 4, then square it, plus, now let's do the same with the y's, the 3, subtract the negative 1, and square it. Okay, take the square root, 2 minus 4, that's negative 2, square that. 3 minus a negative 1, that's 4, square that. Negative 2 squared, negative 2 times negative 2 is 4. 4 squared, 4 times 4 is what, 16? So now 4 plus 16 is 20, the square root of 20. And again, it says to approximate, estimate the distance. The square root of 20 isn't a perfect square, so I'm going to use my calculator. Come in, type in the square root. If you don't know where the square root button is, it's right there above the x squared, so it's second x squared. The square root of 20 is approximately 4.4. We'll go 4.47, 2 decimal places, miles. Well, our estimate was pretty close. We said in between 4 to 5 miles. So 4.47 miles using the distance formula. For right now, when it comes to square root, things like that, we're going to approximate, but we will learn some skills on how to simplify that, and I know you did it last year in Algebra 1, how to simplify those. Okay, so now, there's no year term problems for this section. Okay, so now just go ahead and get started on the practice, which is located, the list of problems is located below this video. Okay, good luck.